In this lesson, students are comparing linear, quadratic, and exponential functions. So in this warm-up, I wanted to focus in on a quadratic function since in the previous lesson we were comparing exponential to linear, and those two functions they have studied the key characteristics of more than the quadratic function at this point because we haven't done the quadratic unit. And so when we look at the quadratic function or the equation, they know that most of my students know that area equals side squared is the area formula, or some of them will say length times width. So we have the discussion that a square is always a rectangle, but a rectangle is not always a square. So you could find the area using the same formula, even though most of the time, since the side lengths are the same on the square, we say it's s times s or s squared. You also could write it as a function a of s equals s squared. And then I talk about the table, really concentrate on the table of how they recognize if it's quadratic by looking at if the x coordinates are in sequential order. Then you can look at the output values and see that if you subtract 4 minus 1, you get 3, 9 minus 4, you get 5. When you look at those differences, when you subtract that previous amount, you don't get a common difference, so you know it's not linear, because remember, linear has to get a common difference. But if you look at the second difference, 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2, 11 minus 9 is 2, you do get a second common difference, and that is a key characteristic of quadratic functions when you're looking at the table. So it is quadratic, it's s squared, it's degree 2, the power of 2 instead of the power of 1 for linear, and it also has a second common difference. So those are two key characteristics of quadratics that'll tell us it's a quadratic function. And then I also wanted them to see this warm up because a lot of the times when we look at real world problems, we have a domain that's restricted. And in this, the domain, the side lengths of the square are never going to be 0 or never going to be negative. So it's going to be all x values that are positive. So x is greater than or equal to, or greater than 0. It won't be equal to a side length of 0.